In this video, we'll see how the solar tracker works.
This is an indoor test of the solar tracker. I'm using my phone camera's flashlight as the light source, so the solar tracker will try to align with the camera. For the next test, I'm using a torchlight. Turn on the circuit. And as you can see, the solar tracker is slowly aligning to the light source.
This is the sensor array. As you can see, the sensor on the left is shaded while the sensor on the bottom is shaded. This means that there is misalignment of the solar tracker with respect to the sun. Therefore, later on when I turn on the circuit, you should see that the tracker aligns with the sun properly. As you can see, it is aligning with the sunlight direction. Since this is a solar tracker, then no matter how I place the table, the solar tracker should still be able to align with the sunlight properly. So as you can see, the tracker still track the light direction correctly. Let me quickly put the table back in place. See, it's back to the original position.
Here are the experiment results. I'll be showing how I measure the voltages and currents from the solar tracker and static solar panel. In conclusion, I'm very happy to successfully implement a dual assist solar tracker without using embedded system. I've learned a lot of technical skills from this FYP project.
Alright, that's it for this video. Thanks for watching.